This is the Turing Pi 2 board, and it has 4 of the world's fastest ARM SBCs, these new RK1 boards. This board is the new SBC Cluster King. It has 32 CPU cores, 24 TOPS of AI compute, 128 gigs of RAM, and I put 4 terabytes of fast NVMe storage on the bottom. This thing is so fast, it even beats the pants off this 6-node Raspberry Pi cluster board. This video is sponsored by Squarespace, and I'll tell you more on them later, but I already talked about the motherboard here, the Turing Pi 2, back in December 2021. Basically, this is a mini ITX cluster board that holds up to 4 computers. Each of these slots has power, I/O, and networking, so you can build your own tiny little Kubernetes cluster or use it for experimenting or storage or whatever. What this doesn't do is give you one super fast computer. You still get 4 individual computers just conveniently put together in the same space as a normal single PC. But back in 2021, the main SBC you'd use with it was this, the tiny Raspberry Pi Compute Module 4. And the Pi's a neat little SOM, or system on module. They start at $35 and you could get up to 8 gigs of RAM per Pi. But this thing came out in 2020. These new SOMs, called the RK1, these come with CPUs that are 5 times faster. They can use blazing fast NVMe storage at over 1 gigabyte per second, and they have built-in NPUs for on-chip AI. Oh, and they start at $150 at the low end. Being the fastest ain't cheap. Yeah, it's a lot more than the Compute Module 4, and if you go for the Royal experience with a full 32 gigs of RAM, you're looking at a whopping $300 per module. That puts the total price of this board I'm testing at $1,500. And full disclosure, I bought this board and 4 8 gig modules with my own money so I could make this video. But then Turing Pi sent me 4 32 gig modules to test since they wanted me to see how the thing performs maxed out. But I was still happy to spend my own money on the cluster, and I plan on keeping it deployed in my studio. Considering what you get, for some people like me, it's not a terrible deal, but I wouldn't just go out and buy it on a whim. But let's talk about what is terrible. The elephant in the room, the one thing that really derails this board's potential is these 2 Ethernet ports. These are both 1 gigabit, and this is a massive bottleneck. Almost anything you want to do in a cluster environment needs to be able to move data in and out. And 1 gigabit ain't much. Sure, there's also some PCIe expansion, but the easiest way to copy things to and from the cluster is through the built-in networking. And consider this. These compute blades, even though they use the slower Pis, each one has its own independent gigabit connection to your network. So 10 Pis, 10 gigabits of bandwidth. On the Turing Pi 2, the internal network is crippled by just having 1 external gigabit port. It's an architectural Achilles heel with all these cluster boards. And until one of them gets built-in 10 gig networking, it really limits their potential. Now, there are some things on this board that improved a lot since the first time I tested it. The built-in BMC, or board management controller, has a great web UI now, and you can do things like control power to each node or reflash them straight from the web. Other boards like the DeskPi Super6c I have here make you plug a USB cable into each one of the ports for each node, so managing a board like this one remotely is almost impossible. You could drop this Turing Pi 2 somewhere remote and never have to touch it again. All the important stuff is managed through the BMC, kind of like IPMI on a server. There's also a pretty strong community around the board supporting it with drivers and OS releases. But I can't help but feel let down when I have so much potential, but I can't tap into it except for a very narrow set of use cases. Like, it has these 4 NVMe slots on the bottom. And with these RK1s, I can write to each one of those at 1.5 gigabytes per second. That's double what I can do with even a Raspberry Pi 5. But what good is that when between nodes I can only copy things at like 120 megabytes per second? It's still cool to learn Ceph storage clustering on a board like this, but it could actually be used in production scenarios if we had 10 gigs or heck even dual 2.5 gigs. To be fair, the Compute Module 4 also suffers from that same problem on this board. And it also suffers from a lack of performance. These RK1 modules, they don't have that problem, and that's because each one has a speedy RK3588 chip. This chip has 8 CPU cores, an NPU or neural processing unit, and a little iGPU built in. And everything about it is faster than the Compute Module 4. It's even faster than the chip on the Pi 5, so when a Compute Module 5 comes out, this will still be the fastest, barring some sort of miracle. To illustrate that point, here's the Geekbench score for each of the chips. But Geekbench is a synthetic benchmark. Let's look at something that really matters, at least if you're like me and you compile Linux multiple times a day. In both cases, it's about 2 times faster than the Pi 5 and about 5 times faster than the Pi 4. Then there's high performance LinPack. I like this benchmark because it's what the fastest supercomputers in the world use to compare performance. And here again, the RK1 trounces the Pi, 2 times faster than the Pi 5 and 5 times faster than Pi 4. But what's really crazy is the efficiency. It's not only faster than the Pi, but unlike Intel's historically fast but inefficient CPUs, it's also more efficient than the Pi, meaning it does more work using less power. And that scales from 1 node to 4. The RK1 performs better in a 4-node cluster, and it's twice as efficient. Now, the Compute Module 5 hasn't been released yet, but even when it is, barring any miracles, the RK1 is going to stand as the SBC cluster king for a while, especially considering it tops out at 32 gigs of RAM. That's 4 times the amount of RAM on any Pi right now. So we've established the RK1 is fast and expensive. But one of the most annoying things I run into with a lot of Pi projects is deployability. For a lot of these projects, sure, you can slap together some circuit boards, but putting them out in the wild means you need a case or an enclosure or just really anything to protect it. The great thing about being mini ITX is the Turing Pi 2 can fit in standard PC enclosures. And over a year ago now, My Electronics sent me a prototype of their new dual mini ITX rack mount enclosure. You can mount 2 mini ITX systems side by side in a standard rack in 2U of space. But this thing has a party trick. The 2 sides can be separated and it turns into 2 mini 10-inch rack mount enclosures. But that's not really useful without a 10-inch mini rack. DeskPi, who happens to make that Super6c board I mentioned earlier, also just started making the Rackmate T1, an 8U mini rack that you can stick on your desktop or take anywhere. And they just sent me this one to test. I've wanted to get into 10-inch racks for a while, so this thing is perfect for me. It has an open back, so even though I think this My Electronics case will stick out a little bit, it should be fine. But my goal is to put all these things together, get my first mini rack set up, and then deploy Kubernetes using my open source Pi cluster project. I'm going to focus on getting this set up first, so we can set this back down over here, and get some things moved away. And this is the first time I'm taking a look at this box, so I hope that it includes all the accessories. I mentioned that this was a prototype they sent. This was before they actually released the product. You can buy it now. You can buy this on, I think, Amazon even in the US. But I'm going to try it. Looks like they threw in a few parts. This is the 10-inch rack faceplate, looks like. And it looks like their power button is actually a keystone power button. That's kind of cool. I was going to say there's no place for a power button, but then I noticed that this is a keystone. I like that. They included this little goodie bag, which has a blank for the keystone jack, some screws. These are for SSDs and hard drives, and then some more screws. Don't know what those are for, maybe case screws, and a teeny tiny half-height PCI Express card slot cover. So this is cool. If I can get it open. Maybe black acrylic covers. So you could actually use this as a desktop enclosure too. You don't have to have it rack mount. Because my ultimate goal is to maybe have this system be RK1 boards, and this system, if the Compute Module 5 ever comes out, this could hold 6 Compute Module 5s, and we could do some more comparisons. My guess is that 6 Compute Module 5s would probably be getting close to the performance of 4 of these RK1s. But I don't know until we get them. And I just saw news on the Raspberry Pi EEPROM, the latest firmware for the Raspberry Pi. It has support for CM5 baked in, which means they must be getting closer. And it had some configuration for a new D0 stepping. So I think the Pi 5 has a C0 chip, and D0 means that they would have made some revisions to the silicon. So maybe the new BCM2712 D0 is a little faster. I don't know. Maybe it can be clocked higher. We'll see. But I'm not going to use these for now. These little heat sinks have built-in fans, so just the passive airflow in this case is probably enough. But I think that there's a mounting pattern for a 60mm fan on the front of this case. And if there is, I'm going to put this Noctua fan in there. And I believe that there's a fan header on here, maybe? No, there is a fan header, but it's only 2 pins. So I'm guessing that's power, and yeah, I can plug that in. So I think that might just be power and ground. Ooh, I almost lost that one. And yes, I know I could put down a mat here. I might do that someday, I don't know. Okay, so that comes right off. That is the 19-inch rack mount faceplate. So now you have two cases, and there are mounting holes for that fan, and there's a power button and then a blank in here. And I think the first time I ever got something from my electronics, it was using hex bits, which is relatively standard, but less standard, I think, at least in North America. And I had suggested they use Phillips. Even though Phillips is not the best thing in the world, they're everywhere, and everybody has one of these little Phillips screwdrivers. Since we won't have a PCI Express card in this build, I'm going to go ahead and install this card slot cover. And screws are lined up. And I probably should have installed the fan before this, but that's okay. I'm going to use it as an intake. Okay. Get out my box, and there's my screws. Put that aside. Let's grab 4 of these guys. All right. There is a little fan header right here, but it's only 2 pins, and I need to check the pin out on that because I could plug this straight in, but I don't know if that's just power and ground right there, or... You know, it's funny, there's actually an unpopulated socket right here for a fan, and that would be perfect because I could just go boop like that, but I don't know why that's not populated on mine. Another thing that I need to do is get power. So I have these front panel connectors, which go right here underneath. All right, so I found the front panel pinout on their website, nicely illustrated. Power LED and ground are there. And if you really wanted to cable manage, I could zip tie those, but I'm just gonna leave it like that for now. So I'm going to just plug this in and hope that it's ground and 12 volts. If it's not, we'll see what happens to the fan. Worst case, we'll just have a little bit of smoke come out of here. And for power, since we're in this tiny case, you can't really do an internal power supply. Even Flex ATX is too big. So this is really designed for projects where you can use a Pico PSU. I bought this one off Amazon. It's the RGeek 250 watt PSU. There's no more specs on it, but you can find Pico PSUs from a lot of different places. It's nice because it has, you know, CPU pins, I think. It has Molex and it has SATA power. And you can even take these off because I don't think I need any of those, do I? No, I can even take this off because I won't need those on this build. But it basically breaks out an ATX 24 pin connection into a 12 volt barrel plug. And I could even put this on the back somewhere. There's nowhere, oh, there is a little spot here. I wonder if this will fit. Look at that. They thought of everything in this case. So this will be our power supply connection. And then this just plugs in here. One issue is these 2 leads are going right into the fan. Let's see if I can safely bend these out of the way. We might be hitting some fan blades here, but you know, all's well that ends in not a fire. But it'd be kind of fun to see if the fan blades can slowly slice away the insulation on here. But right now, the fan blades have about 2 millimeters of space, so I'm not too concerned. I am more concerned about wrenching on those connections. It might be a good idea if you can get a low profile 60 millimeter fan. That would solve that problem too. But everything is connected now, and it looks pretty good inside. That's pretty sleek. I like this case more than I thought I would. Kind of pops into place here. It's kind of a fun look. Just ram some air in there. And actually, this is held off by about 4 or 5 millimeters from the front of the fan, so that actually will help with the noise. But let's get these 2 screws in to hold this plate on. And the fact that there's only 2 screws holding it in and no other real support, I don't think you'd want to put a really dense system inside of one of these, because you're holding all that weight from this faceplate onto the body of this through these two screws. It can probably hold maybe 5 or 10 pounds, but if you put a pile of lead in here, it would probably rip off. But it's pretty solid, and if I had my ATX cover on here, it would look a little nicer in the back. It also has 4 keystone jacks in the back, so that's a nice touch. But that's it. That's our little case. Now we need to set up the rack to put this into. I have not taken a peek inside of this thing yet, and it's actually probably going to be easier to open it on the ground. But let's see what it comes with. I think I saw it was $120 on DeskPi's website, but on Amazon, it was showing as $199. I don't know what the final price is going to be, and I'm not sure if it includes everything that I have in this case, but I'm guessing it does. Let's check it out. Okay. It feels solid. The top is acrylic with some ventilation. Whoops, there's a box in there. And the sides are acrylic with kind of a smoked glass look. This comes with, let's see, there's a panel on the bottom that looks like it has fan mounting holes. Then there's a blank. This blank is actually bent just a slight bit, so I wonder if in shipping it got crushed a little bit. There's a shelf, and this is a shelf with a lot of mounting holes. I think that this lets you mount 2 NVIDIA Jetsons or Raspberry Pis or different things. And I think you can mount hard drives or SSDs underneath it too. That's interesting. Both sides have holes, so you can actually do it from either side. You could have some things come in from one side, some from the other. The depth of this, I mentioned earlier, is not quite deep enough for this, but since the back is open, this should just be able to go through. Since this is a bit heavier, I'm probably going to mount it down low. LTT, you're failing me. You don't have the right size hex bit. I wonder if it comes with something. Let's see. Ah, look at that. They include the tools. How nice. But you can find out more about this DeskPi Rackmount T1. I'll have a link down in the description. I'm going to pull this big shelf out right now. The shelf will be nice if I want to... Oh, well, that's interesting. I thought this was just straight up through, but now it makes sense. This shelf goes onto this little tray that's in the back. See, these little guys are just holding that shelf on. And this shelf is useful for things like a network switch or little power distribution. You know what's funny is, in Europe at least, there's a pretty decent number of 10-inch mini rack options. In the US, it's really hard to find them. And that's kind of disappointing. I think that this kind of rack, like, look at the size of this thing. This would be perfect for a little home lab. Especially if you're in an apartment or somewhere, you can grab it and take it with you. You can fit this almost anywhere. And a lot of things like mini PCs fit perfectly in here. If you have, I've covered many of them on my channel. Raspberry Pis, of course. Let's see if this fits in the bottom here. Uh-oh, oh, there we go. And there we have it. One thing I have never seen is a half rack UPS. It'd be cool to make a little 1U or maybe even 2U UPS for this thing. Then you could literally unplug it from the wall, take it somewhere, set it down, plug it in, and it would still be running. That's, I don't know. To me, that seems pretty cool. I don't know about you, but I see this and I think of a lot of possibilities. And I don't know what thread pitch they use on here. I'm going to have to go grab a couple of my rack screws and find that out. That's solid. And you can see it comes out the back just a teeny tiny bit. It's not bad at all. And when we plug in power, the power cable will just pop right out here like that. And network goes here, and we'll have a functional cluster. This is an 8 amp 12 volt power supply. And that should be plenty for this this setup with the 4 RK1s. I'll plug networking into one of the ports on the back. Power can go in over here too. And the board is powering on its BMC. There's a few LEDs that are on. Another thing that could be improved with this particular setup is having LEDs either on the back or the front. One thing I did like a lot about the DeskPi Super6c is it has activity LEDs for each node on the back. So if you look at the back of it, you can see which ones are doing stuff or powered on. It's a little harder to see on this once you put it into an enclosure. It looks like everything is up now, and the fan is on. So that's good. I can feel the air coming out. And the power came on. So I guess it boots itself the first time. And I see all the nodes LEDs are on. So let's go on the network and check this out and see what we have. I did check the rack screws, and they are 1032 threads. So you can get standard rack screws, which is nice, and replace the screws that come in the kit if you want. That way, for me, it's nice because I can use Phillips head for everything. The other thing I did was when I pulled out the box, I took the cover off and I put in Noctua's low noise adapter. So the fan is about half as loud, and it could probably run without a fan at all. Honestly, because the heat sinks have built-in fans. But now that everything's booted up, it's on my network, and I have this playbook. It's an Ansible playbook called Pi Cluster, and this is not Raspberry Pis, but they are Turing Pis, I guess. But they're RK1s, and this playbook is what I use for all my cluster testing. So it basically does a lot of things to it. It can benchmark the cluster, it can set up storage, it can set up Kubernetes, which is what we'll use today. To make it so that instead of having 4 separate nodes, you can have 4 nodes together in a cluster that you can do useful things with. Since I'm running Ubuntu and not Debian, Debian or Pi OS 12 includes Network Manager out of the box. So with Ubuntu, there's actually a step that I had to do. And there's a playbook that I have called Ubuntu Prep, and that sets up Network Manager instead of the whatever net plan that's set up in Ubuntu by default. So I did that already. And the next thing that I need to do before I can deploy Kubernetes to it is set up static IP address networking. If you don't have static IP addresses, Kubernetes gets really confused, at least if you're like me and you want to use fancy host names. So in my case, I'm using Turing1.local, Turing2.local, 3, 4, and I already set those up when I flashed the nodes. So if I say SSH Ubuntu at Turing1.local, I can log in using my SSH key, and that way I don't have to know what the IP address is. It doesn't matter to me. I use the DNS names. But because MDNS is a little funny, and it might be using IPv6 like this, or it might be using IPv4, it's best to be very explicit about it. So we're going to set up static networking, but this is the inventory file that Ansible is going to use to know how to connect to the different nodes in my cluster. And then I also have a config file that tells Ansible some other details, like this is my subnet 10.0.2. whatever, and the dot whatever is these octets, the last one. So the first node, Turing Pi 1, will be 10.0.2.91, and the second will be 92, 93, 94. And so I'm going to run that playbook, the static networking, which is here. This is a networking playbook that runs a few different networking tasks. In this case, just setting up static networking. Well, first let's make sure we can connect to all the nodes. You can run this command, Ansible all-m ping. This is basically going to send a ping out to each node over SSH, and if it can work, then it shows success, which it did. Good job. Thank you. Then the next step is I'm going to set up the static networking, which is this playbook. And that hopefully will just work. It should set up the hosts file to make sure that each of the nodes can connect to each other. And once it finishes setting up static networking, it's best to just reboot. You can actually use it this way, but I like to reboot so that it only has the static IP address and doesn't have any potential collisions. So I'm going to run this command. It will reboot all of the nodes and wait for them to reboot. Once they reboot, Ansible will come back and say it's successful. So the main playbook will set up Kubernetes, and it will set up some configurations. This particular thing has some demonstrations like running Drupal inside of your Kubernetes cluster, which is a nice kind of challenge because Drupal is a fairly heavyweight PHP content management system, and it requires a MySQL database, which requires persistence. So you're really testing the full breadth of capabilities of your cluster when you run an actual real-world application like Drupal with persistence and with front end and all that kind of stuff. So I'm going to run this playbook, and it takes, I don't know, between 10 to 20 minutes, depending on your internet connection and everything. And I just noticed that I have another bug in here that expects the user Pi to be present. But when we're running on these Ubuntu nodes, Pi is not the user that's used. So I have an issue for all these little bugs. And if you want to run this playbook on your own system and you find any problems, feel free to open an issue. That's why it's open source. So I should just use Ansible user. Ansible user. Okay, so now let's try running that again, and we'll see if it works. It should use the user Ubuntu instead of Pi. There it goes. Now it's working. Okay, the cluster is deployed now, and I'm going to log into the first node, Turing 1, and check if I can see Kubernetes running and see where the pods are located. Pods are basically little units of work for Kubernetes. And there should be like a Drupal pod and a MariaDB pod, and they should be all working together, and we should be able to access Drupal. We'll see if that works. So logging into Turing Pi 1, and if I change to the root user account following the README that's over here, I should be able to use kubectl or kube control to see if the Drupal pods are running. So let's check that out. And it says pending. So that's not a great sign. That means something's up. Let's get all pods. And so a lot of pods are there. It's creating the NFS pod, which means there's probably an issue with the shared file system. The way this playbook is set up, it's supposed to set up a shared NFS folder on node 3, I think, by default. And that might be failing because this is Ubuntu and I was running it on Debian, and there might be some path issue or who knows what. But I'll get that sorted really quick, and we'll see how this works. So a quick overview of Kubernetes. There's a command line utility called kubectl or kube control or Kubernetes control, whatever you want to call it. But kubectl is supposedly the official name for it. But we can say kubectl get and then nodes. That shows us all the nodes that are connected. And it's seeing that Turing Pi 1 is the control plane / master node. And the other ones are just worker nodes. I can also get pods, and if we do these things, it does it in the default namespace, but you can use namespaces in Kubernetes to do special things like isolate apps and things like that. So I isolated Drupal in the Drupal namespace. If we do that, we can see that these two are pending, and this is a common thing when you're setting up Kubernetes clusters. You're going to have weird issues, like this one says container creating, and that means it's probably having some issue getting set up. And there might be a problem. It might be something that you're using a pod that doesn't run on ARM, or you have a pod that requires some resource that's not available. So I checked the NFS mount. So if I do this, I can see that mount is here. Kubectl describe pod this. Let's see, it says mount failed exit status 32. Through the power of Google, I found this issue, and someone had suggested make sure that you have NFS common installed on all your nodes. If I scroll down here. So I will add that to the playbook. I wonder if that's actually on PiOS by default and not on Ubuntu, and that's why I didn't see this problem on my Pi clusters. Oh, there we go, started container Drupal. So if we go here, we can see that both are running, and that's saying that I could go to any of these nodes on port 80 and it should work. So let's try that. We can go to Turing1.local or 10.0.2.91. If we go here, look at that. There's Drupal installer, save and continue. Let's see if it installs with the Umami Food Magazine install profile, which is like a demo site. I also noticed this happens in Drupal sometimes. This seems to be a Drupal issue. But if you just try again, a lot of times it works. I don't know why it doesn't work the first time. But here it goes, installing Drupal. And this is actually kind of fast. This is faster than it is on a Pi 4. I haven't tested this on a Pi 5 yet, but installing Drupal seems to be going fairly decently on the RK1. So while it's doing that, we can also check where everything's deployed. So if we look at this column here, which is the node, we can see that there's some things on Turing 1. This is on Turing 4. MariaDB is on node 4. And Drupal is on node 2. So Kubernetes has done a pretty good job of spreading things out. So it's running Drupal on node 2, MariaDB on node 4, and if we have scaling rules set up in Kubernetes, it can actually scale and run instances of Drupal on other nodes. I've run through the Kubernetes setup. I fixed a few bugs in my Pi cluster playbook so it works with Ubuntu and the RK1, and now I have a working cluster. I could deploy really any Kubernetes workloads here as long as they have ARM containers. And just clicking around while I'm logged into the demo site feels a lot faster than when I ran it on my Pi cluster. It's not perfect, and the gigabit network between the nodes leaves some performance on the table, but this is definitely a step up from my Pi cluster, and I think the RK1 boards will definitely hold on to the SBC cluster performance crown for a long while. Now, you might think it's fun to compile your own Linux kernel or self-host a website on a mini Kubernetes cluster, and I'm in that group. In fact, I host a bunch of websites on my own. But I wanted to make a better online store for my merch since I'm switching to a way better t-shirt supplier. I mean, you can see this old shirt's already pilling, and it's only been through like 8 washings. For my new store, I'm using this video's sponsor, Squarespace. I already mentioned how I got a full store site set up in less than an hour. And I integrated it with my bank for checkout in just a few minutes. Squarespace smooths over all the hard parts of building a website, and they let me focus on design, adding products, and getting redshirtjeff.com ready for a relaunch. Not every self-hosted app's a good fit for Squarespace. I mean, it can't replace Jellyfin, but especially if you're a small business and you want to avoid the hassle of building your own system or running your own servers, give Squarespace a try. Go to squarespace.com for a free trial, and when you're ready to launch, go to squarespace.com/redshirtjeff to save 10% off your first purchase of a website or domain. Until next time, I'm Jeff Geerling.